Let's see how we can do with this one. So my first question, and where I'm always starting all of these word problems at, is what is it that we're wanting to know? Because that's going to determine how many variables I need and therefore how many equations I'm going to need. Aiden. Okay, so we want to know how many grams but don't we know that answer? We need 450 grams, right? So what is it that I'm wanting to know? Be a little bit more specific for me. We want to know how many grams. Yes. So we have two different types of solutions. So how many grams of the 5% solution and how many grams of the 95% solution? Since we're looking for two different things here, I'm going to need two different variables, one for each of the things that I'm trying to find. You guys okay with X and Y? Okay. So I'm going to have X mean the number of grams of 5% solution. And I'm going to let Y be the number of grams of 95% solution. So the first place you need to start on any story problem is, what is it that I'm wanting to know? Do you want to know one thing? Do you want to know two things? If you want to know just one thing, you are most likely going to only need to define one variable. And most likely, you will only need one equation if you're only looking for one thing. Sometimes there are two unknowns, but the question is only asking about one of those. In that case, you would still need two variables. If there are two unknown things that you have to use together to find the thing that you're interested in, then you're going to need two variables. However many variables you have, that is the minimum number of equations you will need to write. If there are two unknowns, you're going to have at least two equations. If you've got three unknowns, you would have to have at least three equations. If you only have one value that is unknown that you're looking for, you would only have to have a minimum of one equation. Since we're looking for two things, I'm going to need two equations here. And each of my equations is going to need to take both of these variables into account so that I can then either use elimination or substitution to get rid of one of those variables and narrow it down to just one. So what kinds of information do we have about what we want from our final product?
Total amounts of grams will equal 450.
Total amounts of grams will equal 450. So if I do, I'm going to call this total volume. 450 is my total, and it's going to be made up of what?
X and Y.
X and Y. We're going to dump some of the 5% solution in, dump some of the 95% solution in, and together we want that to be 450 grams total volume. So far, so good? Okay. So that's one of my equations. What else do we know we want in our final product? Yes, sir.
Percentage of alcohol.
Percentage of alcohol. We want it to be a 75% alcohol by weight bactericide. So I'm going to call this concentration. And I'm going to use this equation to just talk about the amount of alcohol present in each of these different things. So we know we want it to be 75% alcohol, but 75% of what? 75% of that 450 grams at the end needs to be made up of alcohol. So 0.75 of 450 is equal to, and now I need to talk about the concentrations of each of these. So what would I put with the X then?
0.05.
Yes, 0.05X together with,
0.35Y.
yes, 0.95Y. And then once I get it to this point, I can solve it like a system. I am going to need to simplify this little bit over here. What is 0.75 times 450? For speed right now, go ahead and pull out a calculator. Obviously, tests and quizzes, you can't use calculators, but for right now, go ahead and pull a calculator out. 337.5 equals 0.05x plus 0.95y. And then we can choose either substitution. I could take that equation that I wrote in red and I can solve it for either x or y. And I could substitute into my orange equation. Or I can use the linear combination, the elimination method, where I would multiply that red equation either by negative 0.05 or by negative 0.95. What method do you guys want to do this morning? Substitution sounds good. Do you want to solve this equation for x or for y?
For x.
Okay, let's solve it for x. So I would have x equals 450 minus y. And then I'm going to take that, and it's going to go in here for this x. It's going to take the place of this x. So I would have 337.5 equals 0.05, and then I do my substitution here. 450 minus y plus 0.95y. We're going to distribute this piece. So again, grab your calculators for me. I need to know what 5% of 450 is. You said 42.5? 22.5. I just didn't hear right. You said 22.5? I'm trusting you guys right now. 22.5 minus 0.05y plus 0.95y. I can combine these two together and get just 0.9y. And I'm going to subtract the 22.5 from both sides. So I would get, what is that, 315 on the other side?
Yeah.
315 equals 0.9y. And then I would divide both sides by 0.9. What do we get when we divide that? 350. What did we just find? Grams of 95% solution. So if that's how much of the 95% solution I need, how much of the 5% solution do I need? 100 grams. 450 minus 350 to get x. So 100 is x. I don't have to see much as far as work goes for that second variable, but I do need to see a little something. Just show me what you did. If I see 450 minus 350 and then you say, oh, I need 100 grams of this, that's enough work for me, but don't just leave that part blank. So final answer, we need 350 grams of the 95% solution and 100 grams of the 5% solution. I figured we'd start tomorrow off with another story problem, and I'm planning, we'll see how we do, but I'm planning on having time towards the end of class today to take questions over 2.2 because there were a lot of questions over 2.2. So in the interest of efficacy, speed, and equity, we'll take time for questions at the end here. All right. We had left off yesterday. We had done some solving by factoring. Today we're going to look at completing the square and then using completing the square to solve. So when we use the method of completing the square, I want this to be a perfect square trinomial. I should write at the top that that's what I want. I want a value for D there so that when I factor this, I get two identical factors, like x plus 5 times x plus 5, or x minus 2 times x minus 2. Whatever that value for D is, I need to make sure that it would force this to be something that is a perfect square. Does that make sense? Okay. So if you remember, when we go to square a binomial, write this off to the side. When I square a binomial, like a plus b squared, how does that expand? A squared plus 2ab plus b squared. On part A over here, I'm in effect trying to figure out what this would be, what b squared is. That's what would take the place of this d that I have right there. So far, so good? That needs to be b squared over there. I know my middle term is 9x. I know that a is x, because a squared is x squared. How can I figure out what that value for b is? So I'm going to take this value right here. I'm going to divide it by 2x. That'll give me what b is. And then I will square it. So I'm going to take this middle term and write it down over here. I need a different color. Take that middle term, 9x. I'm going to divide that by 2x so that my x's cancel out. So now I have 9 over 2. This is b. And on the end, I need b squared, so I need to take that and I need to square it. What is 9 over 2 squared? (81) over what?
4.
Over 4. So this is what I would need the value for D to be in order for this to be a perfect square trinomial. I want you guys to try that on part B up there. Figure out what value could go in the place where that letter D is so that we would have a perfect square trinomial. what should that value for D be? 16. So I'm going to take that negative 8x. I'm going to divide it by 2x. So I end up with negative 4. And I need to square it. So 16 is what I should put in the place of this value for D. If I had 16 in the place of that value for D, x squared minus 8x plus 16, how would that factor then? X minus 4x minus 4. So we would have x minus 4 whole quantity squared. What do you notice about the relationship between how that factors and what we did to find that value for D? Where else did you see that minus 4 show up? That's what we needed to square. This value right here, when we took that middle term and cut it in half, chopped off the x, that will be this piece right here. So if I use that same thinking, can you guys help me figure out how the first one would factor if I had 81 over 4 in the place of D?
Plus 81 over 4.
Not plus 81 over 4. X plus 9 over 2. Whole quantity squared. Does that make sense? Okay. On parts C and D, it's not that end piece. It's not this b squared that I want. This is what I know now. What piece am I wanting? I'm wanting this middle term, this 2ab, right? It already has this part. That's the x piece. We already have this. So it's really just a 2b right there. How do I figure out what b is? Yeah. I've got this part right here. This is b squared. So b is what? 6. This middle piece right here is 2ab. We know that that is x. So 2 times b. What are we going to have as this middle term? 12. We need 12 here. So that it would be x squared plus 12x plus 36. How would x squared plus 12x plus 36 factor? X plus 6, x plus 6, or x plus 6 quantity squared. Remember, our goal is to get that squared binomial. That's what we're trying to create. That's the whole idea of completing the square. We need this other value in order to make it complete, and then we have a squared binomial. What about the last one here, part D? What do I need to do? I need to square root this right here. I'm going to do it in green. So that means that b is what? 7 over 2. And what do I need to do to that before I just pop it in the place for d? Multiply it by 2. So what should go here? 7. So I would have x squared plus 7x plus 49 over 4, and because of what we had to do to get that, we should now also know how this is going to factor. What would my squared binomial be here? Yep, x plus 7 over 2 whole quantity squared. You guys feel like you have a decent understanding of how to come up with that missing value? And more importantly, once we have that missing value, how it will factor. Okay, because now we're going to take what we just worked on here And we're going to use this process to solve quadratics. Not solving by factoring, not solving by using quadratic formula. We're going to solve using this method. Okay? So when I'm solving using completing the square, this piece right here, we want to kick to the other side. So I'm going to have to subtract 7 from both sides. So I would have x squared plus 6x. I'm going to put a blank line in there. Right now we know that there's a 0, but that's where we're going to put that missing value that we were coming up with on the other screen. Equals -7. And my rules of algebra say if I do something to one side, I have to do the exact same thing to the other side. I'm not allowed to add something on the left to make it a perfect square trinomial unless I add that exact same amount over on the right. So far, so good? All right. So I need to use this right here to figure out what my value for b is. What do I do to this? Yep, 6x, we're going to divide that by 2x. So my x's cancel, I get 3. And then what do I do to that 3? Square it. That's what I'm going to put here, and I have to do it to the other side also. So I have a 9 in each spot. All right, so cleaning that up a little bit, that gives me x squared plus 6x plus 9 equals 2. We just forced this to be a perfect square trinomial. How will it factor? X plus 3, x plus 3. So x plus 3 squared equals 2. So far, so good? All right. We did one that kind of looked like this yesterday, where I had a squared binomial on one side and it was equal to a value. What's the best and fastest way to get rid of a squared?
Square root.
Square root. If you do it to one side, you got to do it to the other side. So I would have x plus 3 equals, when we take a square root of both sides, we have to consider how many cases? 2 cases, positive and negative. So I'm going to have plus or minus the square root of 2. How do I get the x all by itself now? Subtract it from both sides. So I'm going to subtract 3 from both sides. And so I get x equals -3 plus or minus radical 2. If you write plus or minus radical 2 minus 3, that is exactly the same. It's standard convention in math that if we have radicals and whole numbers, we put the whole number first and then add or subtract our radical. But it's not incorrect. There's nothing horribly wrong about doing it the other way around. All right. Let's look at this one more time. So the first thing I need to do here is what? I need to take this 5 and I need to kick it over. So I'm going to have 2x squared plus 8x. So I'm going to put my blank line in here. Equals positive 5 plus my blank line. And I have something that I'm running into that I haven't seen in any of the previous problems, and that is a leading coefficient that is not 1. What is my leading coefficient here? 2. That's going to throw off when I'm trying to have a perfect square, because remember that first value, so what should come out to give me 2x squared is supposed to be something times itself. What can I take times itself and get 2? Square root of 2, right? I don't want to deal with that. Let's divide everything through by 2 right here. I'm going to divide every single piece by 2. So now I would have x squared plus 4x plus whatever this term is equals 5 over 2 plus this missing term. Help me come up with what should go on that line. What should go right here?
4.
I'm going to take 4x, I'm going to divide it by 2x, so my x's cancel. That gives me 2, and then we need to take the 2 and square it. So absolutely, we have 4 that's going to go on both of these lines. How will this factor now? X plus 2, x plus 2, or x plus 2 squared equals, I have to take 5 over 2 and I have to add it to 4.
You make 4 equals.
I can make that 4 and 8 over 2. So 5 over 2 plus 8 over 2. And what would I get from that? 13 over 2. All right. So far, so good? What do I need to do? Square root. Square rooting means how many cases? 2 cases. Plus or minus square root of 13 over 2. What do I need to do next? Minus 2 from both sides. And so then I have x equals negative 2 plus or minus radical 13 over 2. Does anybody notice anything? Yes, sir. We do need to rationalize that denominator. Because what I have here is x equals negative 2 plus or minus radical 13 over radical 2. Remember that radical distributes to my numerator and my denominator. So how do I rationalize the denominator here? Yep. Multiply top and bottom by root 2. All right, so final answer with a rationalized denominator, x equals negative 2 plus or minus radical 26 over 2. If you wanted to write that as a single fraction, so you had negative 4 plus or minus radical 26 all over 2, you could do that. You do not have to have a common denominator and combine those. Rationalizing that denominator is plenty enough on this one. And I know that radical 26 is not going to simplify, because what is it that multiplied to give us 26? 13 and 2. No perfect squares in there. Let's do one more, and then I'll take questions from 2-2. All right? First thing. Yep. Kick this negative 11 to the other side. So I'm going to have 4x squared minus 12x plus something equals 11 plus something. What next? Divide everybody by 4. Get that 4 out of there. Even though I know 4 is a perfect square, it's going to gum everything up if I leave it there. So I'm going to get it out of the way. So x squared minus 3x plus something equals 11 fourths plus, I don't know yet. What do I put here? 9 over 4, because I'm going to take negative 3 over 2x, sorry, negative 3x, we're going to divide that by 2x. So I would have negative 3 over 2, but then I have to take that and square it. So 9 over 4. How convenient. We have a common denominator over on that other side. So how will this factor? X minus 3 over 2 quantity squared. Absolutely correct. Equals what? 5. 20 over 4 to get 5 right there. Even nicer. Square root both sides. X minus 3 over 2 equals plus or minus square root of 5. And last but not least, we're going to add by 3 over 2 on both sides. Do I need to rationalize any denominators here?
No.
Nope. X equals 3 over 2 plus or minus radical 5. Right. Do you guys have any questions for me about this? Okay. Let's take some questions over the 2-2 homework. I'm not going to go all the way through to the answer, but I will talk about how to go from the story to the equation. Which ones did you guys want to talk about or look at? Yes, ma'am. Very last one, absolutely. Let me come over here. It's not going to let me scroll down. All right, that one was about the running rates. All right. A runner starts at the beginning of a runner's path and runs at a constant rate of 6 miles per hour. 5 minutes later, a second runner begins at the same point, running at a rate of 8 miles per hour and following the same course. How long will it take the second runner to reach the first runner? So I kind of think of this one like this. We've got time and we have distance. Our first runner takes off. Sometime after that, and it tells us how long, the second runner leaves. So our first runner is up here when the second runner starts, because they're further ahead, right? Second runner leaves, they're running faster, so eventually they're going to catch up. We're trying to figure out when that's going to happen. Their distance is the same at this point. We need to figure out what is that time. Well, when I look at it like this, because the timer starts when that second runner leaves, how long will it take them to catch up? Their distance at that point is 0, since they're just starting. So for runner 2, I can write an equation in slope-intercept form. The y-intercept is 0, so it's just going to be their rate. Their distance equals the rate multiplied by the time, right? Yeah, so like y equals 8t, or d equals 8t. For runner 1, there's 2 pieces of information we're going to need. One of them is easy to find. I need their rate, but I also need to know how far ahead they got in those 5 minutes. Because this right here is the 5-minute head start. We know what their rate is, correct? How fast are they going? 6 miles per hour? So y equals 6t plus however far they got on that head start. How can I figure out how far they got in 5 minutes? So 5 over 60. Explain the 5 over 60.
So we're like 5 over 60, kind of like represent like this is minutes. And so like the 60, it's like instead of hours, it's 60 minutes.
Yes. 5 minutes over 60, this will change it into part of an hour. And that's really helpful because our rate is in what kinds of units? Miles per hour. So then we can take 6 miles per hour. That's 6 miles in 1 hour. We can multiply that by 5 over 60 because now this is also in hours. That is a part of an hour. And we end up with what? 30 over 60, which is 0.5 or 1/2, right? So their y-intercept is half a mile. They're half a mile ahead when the other person starts. Once we get it this far, do you know where to go? Okay. What other ones did you guys want to talk about and look at? Yes, ma'am.
The one with the pharmacist.
Absolutely.
Is that the same as the one that we did with the work?
Mm-hmm.
But I still.
Absolutely. Let's look at that one. All right. Preparing eye drops. A pharmacist is to prepare 15 milliliters of special eye drops for a glaucoma patient. The eye drop solution must have a 2% active ingredient, but they only have a 10% and a 1% on hand in stock. So they're going to have to mix these two to get that 2% solution. So I need an X and a Y here. I'm going to let X be the 1% solution, and I'm going to let Y be the 10% solution. You can come up with whatever variables you want to use. Just make sure you're defining them so that you understand what your final answer means. On your quiz, on your test, anytime I give you story problems, you have to define your variables for me. Have to. That's one of the things I'm looking for points. I know that when I put these two things together, however much of the one that I dump in, however much of the other, it needs to give me a total of what? 15 milliliters. So here's my volume equation. What's the other thing that we have information about here? Percent, so concentration. So I have concentration for X, so 0.01 X. I have the concentration for Y, 0.10 Y. And then I need the concentration of this final solution. I know how much needs to go in it. I know what percent of it should be made up of this, I don't know what the active ingredient is, but I know what percentage it needs to be, and I know the amount. So I need to multiply those two together to figure out how much active ingredient is present there. We want it to be a 2% solution of 15 milliliters, so 0.02 times 15. And then we can solve this using substitution or linear combination. I know I'm cutting into our announcements time, but did you guys want to talk about a couple more problems? Okay. What else do we want to look at? Aiden. Question 1, absolutely. Nope, wrong button. There we go. Final class average. Okay, so this is actually very similar to the way I calculate y'all's grades because each different category has a different weight. What it's saying is that final exam carries a 1/3 multiplier. So whatever you get on that final exam, I would multiply it by 1/3. The other 2/3 of the grade are coming from where? From that test average. So we've got 1/3 that is being made up of the final exam. Plus 2/3 that is coming from those other tests. And that would give me my final grade. The one that we did in class in the notes that was similar to this, every single test had the same weight. They were all worth 1/5 of that grade. Here, we have kind of more of a weighted average, where that final exam has more weight than all those other tests combined. So I need the average of the other tests. We don't know what this final exam grade is. How do I find the average of the other tests? Add them up and divide. 72 plus 83 plus 65 plus 73 plus 62 over 5. We know what we want the final grade to come out to be. We want it to be a 76. So far, so good? So that X right there is going to mean my final exam score, and then it will only have the weight of 1/3 of the course grade. All right. I know there were 3 other questions on that homework. If your question was about one of those 3, please send me a message. I'm going to try to work in some more time. We will do another story problem example for bell work tomorrow, and we will begin digging into imaginary numbers. 2.3 homework is due when? Tomorrow, Wednesday. Quiz is Thursday, so you have a chance to go home, work on this homework. Come tomorrow, bring me any other questions. We've got one more day to prepare, and then quiz on Thursday.